Let's talk about LeetCode 3256 zero array transform 2. For this question, it gives us integer array nums and also a two-dimensional array query. And for this query, it has left, right, and value. Um, so we know every time it is able to decrease this kind of nums from the left to right into this kind of value range, right? So we can also do reversely that from to add from left to right every time add a value to it, and trying to see if the final array is able to be able to every number greater equal to this nums I, right? Create temporary. So the things that it is instead of asking true return the true and false, it return the minimal possible non-negative number of k that after processing first k queries in sequence, this kind of nums become zero array. So we know if there is m queries, right? In the so if we know if we try to find k, right, from 0 to k, every time um we do one by one from 0 to k, trying to see if these queries are able to get these numbers to zero array, right? We do reversely to use a diff array. So in that case, it will be uh, those kind of every time. Let me um try to see if every time it will be for for every time we are going to do a ON operation um check, right? So if even we do a diff array, so that will be an NK, right? NK multiplied K, right? So if we, but the things that we can do binary search for the correct times, right? We know um, the worst case is that it have m times, and the optimistic is zero times, right? Let's say yeah. So we just query how many times with binary search how many times it can get these nums into zero array, right? So in that case, if we do binary search this k square, we can change to k log k, right? Um, so so uh, the things that we still need to do so we just write in the help functions um, about is valid, right? Right, help function is valid. So the is valid is pretty much like the same as zero array transform one, right? We use diff array, which have a length n plus one, right? And but now we use query every time we add a query two at the start and minus query two at the end plus one, right? So the other code will to check whether it is valid or not. It is the same. We go through the array, make sure that this kind of compose the array, every number is greater equal to this num size, right? And we binary search this from 0 to m. So the things that for this binary search, we binary search its index, for example, 0 to m minus 1, right? That means the least case is we have one queries. The worst case is that we use all of the queries. And So we binary search the index. If we binary search index, it's possible we don't need to do any queries, so that if we check this nums already it is already all zero array. We don't need to proceed, right? So let's write code. We can have a Boolean all zero equals true, right? So what we do is for every num in nums, if num family equal to zero, then all zero equals false break. And so we'll say if all zero, we don't need to do any queries, just return zero. And we're going to have int m equals to queries data length, right? So what we do is that we're boundary search. So from index, right? Those kind of core index. And what the result will be the index plus one, right? So we're going to have int start equals zero and equals m minus one, right? So while this kind of start plus one smaller than n, we're going to have int mid equals start plus and minus start divided by two, right? So I say if is valid nonce queries in the mid, then that means we can get even less queries. We're going to search on the left part, we're going to have end equals mid. Otherwise, else we're going to have start equals mid, right? So that means that because we are find the first smallest k, right? So what we do is if is valid nonce queries start, we're going to return start plus one, right? Because what binary search is search the index, but we search the counts, right? And it's possible that we will also need to check this kind of end, right? Because it's possible that even we do all of these kind of queries, it's not able to get as all zero array, right? So we'll say if these two not valid, we'll just return minus one. So for the is valid function, it is very similar to what we do before. So what we do is that the private boolean is valid going to have int nonce and int. We put this kind of queries. And for this one, it is the index, right? Because we have binary search the index. And in n equals nonce dot length, we're going to have int if array equals new int n plus one, right? Then instead go through the whole queries, we need to just int I equals zero, I smaller equal to ID, right? Because this index and this index is included I plus plus. So we're going to have let's get the query equals queries I, and we're going to have diff query zero should increase by one, and diff query one plus one, which is minus by one. So let's have int current equals to zero, for int I equals to zero, I smaller than n, I plus plus. We're going to have current plus equal to diff I. And if current is smaller than nonce I, we're going to return false. Otherwise, if we go through the whole array, return true. looks like mm, if all zero return, so this is end equals mid, start equals mid if it is valid. So ah, this is not a increase by one, right? So now what we want is that it is increased by the Fourier two, right? Because we this is not just a one dim it is not only it has can increase decrease by some values. So this will be, and also the Python code is very similar. Let's write the Python code as well. Um, so we'll say if all num um, equals zero for num in nums, return zero, right? And then let's have equals length first, and we're going to have start and equals zero and m minus one, right? While start plus one smaller than and mid equals start plus and divided by two, right? So we'll say if is valid, is valid, we can just have mid, right? Then we're going to have and equals mid. Else we're going to have start equals mid. Okay. So what we do is that if it's valid, start return start plus one. Um, if it's valid end return end plus one. And we need to check both return minus one. So we def is valid um index, right? ID, this index is int, and this is return boolean bool. So what we do is that n equals length nums, and what we have is diff equals this one multiply and plus one, right? So, but for I in range ID plus one, we're going to have Fourier equals Fourier is I, and we're going to have if Fourier zero to the plus equal to Fourier two, and if Fourier one plus one to the minus equal to Fourier two. And then we go through this kind of array current equals to zero for I in range and have current plus equal to if I. So if current is smaller than nums I, return false, and otherwise return true. Right? So doing like this, we know um here, this is an ON check. And this is for for this kind of query, right? Queries that is this is OID operation. OID OID plus ON, right? Because that we also go through this kind of n as well. This is OID. This is ON, and we have binary search, right? This is log M, right? So we'll say uh, this is log M. This is an ID, right? So this will be n multiplied by ID log M, right? So let's say ID is proportional to M, right? So this will be OM plus M log M. And this also will be ON, right? So, but we can ignore this one. So the time complexity will be N plus M log M. And the space is that we just create a diff array that is ON.